Hello friends, now we are going to learn Hamiltonian cycle problems that also comes under backtracking. So as you have discussed in previous sessions, backtracking concepts, right, or sum of subset problems, n-queen problems. Similarly, we are going to discuss Hamiltonian cycle problems. Now question is, what is Hamiltonian cycle problems? What is Hamiltonian cycle? In simple way, you try to understand, right, postman problems, salesperson's problems, right? Postman, what it does, he or she will collect all the letters from the post office, travel all the way, right, covering distance, going home to home, dropping the letters, rest of the letters again coming back and giving back to the post office, reporting to the post office. Say they are going to visit 10 home, right? Then their tendency must be there to complete the journey, right, by covering all the homes exactly once and come back to the same post office. It means in this particular journey, post office is only place which is repeating, right? It means for source and destinations are remain same, and remaining all the vertices, remaining all the nodes, as I call it as a home, right? You are going to visit exactly once. You are not going to repeat. It's he or she is going to visit exactly once, dropping the letters and going to other places. So, similar way Hamiltonian cycle problem says that by visiting all the nodes or vertices exactly once is called Hamiltonian path. But we are not saying the Hamiltonian cycle. It means that source and destinations are remain same. It's called Hamiltonian cycle. Source and destinations are remain same. Remaining all the vertices are going to visit exactly once. It's called Hamiltonian path as well as Hamiltonian cycle. So all of you, I think, understood that what is Hamiltonian path. Here we are talking about all the vertices or nodes are visited exactly once. Now, what is Hamiltonian cycle? When you are talking about a cycle, it means what one loop is completed. Same definitions. All the vertices or nodes are visited exactly once except source vertex. It means here source and destinations are remain same. Source and destinations are remain same. You started from the source by traveling all the places. We are coming back to the, so say this is a node, this is a node, this is a node. We travels all 4 nodes, come back to the same source. It's called Hamiltonian cycle. So this cycle is completed. Hamiltonian cycle, a cycle that contains every node exactly once, right? Problem, given a graph, does it have a Hamiltonian cycle or not? What happens for the given scenarios? We are going to check whether cycle is there, Hamiltonian cycle is there or not. It means you are going to use the backtracking and we see that whether really we have any cycle, Hamiltonian cycle or not. But basic funda is we are not going to repeat any vertex, right, except the starting vertex. So let us see how you are going to solve this problem, right? How? So it is A, B, C, D, we have one more vertex, right? So, yeah, A, B, C, D, E. So let us see this example, right? Here we have 5 vertex and you are going to find out the Hamiltonian cycle. Let us see source vertex as A. So if A is a source vertex, say you are going to start from source vertex A. Do you have a path? Remember that in your mind you think in alphabetical order. After A, which vertex to come? B will come. So do you have path from A to B? Yes. There is a path from A to B. Right? So we reach to B now. Now, after B, from B, we can see that there is a path from B to A. So you are not going to repeat because remaining all the vertex are going to visit. What was the condition? That we are going to visit all the vertices exactly once. We are not going to do the partial work, right? A to B and B to A. No, that is not Hamiltonian cycle. That is just a cycle, right? So A to B, no, B to A. B to B, do you have path? Yes, same vertex. B to C, do you have path? Yes. So B to C. From C, we are having path from A to B, B to C, C to A. We can go back. But what I said, that we have to visit all the vertices exactly once, right? Then only we will go back to the source vertex. Since A is a source vertex, we cannot write that C to A. Hence, we have not visited D, E and F 3 vertices. Hence, that is not feasible to go with A. Then C to B done, C to C gone, C to D. So C to D there is a path. So we will go C to D. C to D there is a path. Now from D, we are having path D to A. Again, we are not going to visit because E and F yet to visit, right? So from D, do you have any other path? Yes, D to E. A, we are not going back. We are going to D to E. So let us see that D to E. We are at E. There is a way from here we can go E to C. But from here it leads to C to either B or C to A. We are not visited F vertex. Hence, from E we are going to visit F. We are at F, right? Now we have already visited B, C, D, E, F, and A is a source vertex, right? So till here you can say that it is Hamiltonian path, but not the cycle, because we have visited all the vertex exactly once. Now, do you have any path from F to A? Do you have path from F to A? No, we don't have path from F to A. Hence, these A to B, B to C, C to D, D to E and E to F is not going to make the cycle, right? Until and unless we will go back to A, this cycle is not completed. Hence, this is not considered to be the one of the solutions. So, this is not the solutions. Not a solutions, right? And it is dead end. It is dead end. If it is dead end, we are going to traverse back. Do you have any other possibilities from E? Yes. What is that? We would have gone E to C. From C, do you have any other path? Yes, we can, but it is C to A. So here also we are not getting solutions. No solutions, because we have to visit F. From D, do you have any other way? Yes, D to A, but that we are not going to consider because we are not visited E and F vertex. From C, do you have any other way? Yes. Rather going C to D, you would have gone C to E. If you are going C to E, then what is the other way? Can we go and traverse? Yes. Either from E, we can go back to D. From D, there is no path of F. So we have to go back to A, hence no solutions. Right? From E, do you have any other way? Yes, we have E to F. Now here we have one vertex is unvisited, that is called D. Do you have path from F to D? Because D to F there is a path, but F to D there is no path, hence it is a dead end, no solutions. No solutions. Now, what will happen? We'll go back to B and we'll feel like that maybe from B we'll get another choice. From B, rather going B to C, can we have other path? Yes, that is what? B to F. Now from F, do you have any other way? Yes, what is that? B, F to E. From E, we have a two paths, E to C and E to D, but alphabetical order, C will come first. So let us see that E to C. So A, B, F, E, C, A, B, F, E, C is visited. Now D to visit. Do you have path from C to D? Yes. From D, what is the source vertex? A is the source vertex. Do you have path from D to A? Yes, there is a path. So this is one of the solutions. This is one of the solutions. So this path is called A to B. Hamiltonian cycle. What is that? A to B, B to F, F to E, E to C, C to D, and D to A. Source is repeated, meaning all the vertices are traversed exactly once. Remember that in Hamiltonian cycle problems, you will not have only one solutions, because you are applying the backtracking, we will have many feasible solutions. So we will go and backtrack, right? From D, do you have any other path? No, right? So we have D to E, and E is already visited, so you are not going to visit. Okay. C, do you have any other path? Yes. C to, we have a D, C2 we have A, that A will not lead to answer because D is already unvisited. From E, yes. From E, we have another way. Rather going E to C, we can go E to D. If we go E to D first, what will happen? We are at a D. From D, which vertex is not visited? A, B, F, E, D. C is not visited. So do you have path from D to C? Yes, we have it. And from C, do you have path from C to A? Yes. So this is again one of the solutions. Because you have visited remaining nodes exactly once, except starting of the node. So A to B, B to F, F to E, E to D, D to C, and C to A. So this we got it, second answer. Right? Alright. Now, can we backtrack it? Yes. We go backtrack to F. Do you have any other path? No. From B, do you have other path? No. From A, do you have other path? Yes. What is that? We can traverse from A to C. A to C. Now, from A to C, we have path A to C to B, B to F, F to E. Since C is already visited, so E to D and D to A. This is another solutions. A to C, C to B, B to F, F to E, and E to D and D to A. These are another solutions. Now let us see that if we'll go and find another way from A to C, C to B, C to B, we have done it, but we can go with C to D, D to E, E to F, F to B, and B to A. This is again a solutions. So we will be having many solutions, many dead end. We have to find out all alternative way, right? How many different solutions you can find. Only condition is we have to visit all the vertices exactly once except the source vertex. Okay. So if we will do so, we can get the final answer. So let us see that if we have values like A, B, C, D, okay, all right. So let us see that this is one of the example, and we are going to find out the Hamiltonian cycle. So here source is, say, starting vertex is A. Anyhow, if it is not there in the questions, you can start from anywhere, but generally we are going to start the journey from vertex A, starting of the vertex A. Do you have path from A to B? Yes, we have path. Do you have path from B, A to B, B to A, B to B, B to C? Yes, we have B to C. Do you have path from C to other vertex, C to D? No. C to A we have, but we have not visited other vertex. So C to E, E to D, and D to A. So this is first attempt only we got the solutions. Similarly, if we will go A to C first, A to C first, then C to B, there is a path, but B reach to dead end. A to C, C to B, B to A, there is a path, but we are not visited D to E. So hence it is dead end. So you go back track to C and check that do you have any other path? No, right? So let us see that C to other side, we have path called C to E and E to D. Now D to A there is a path, but B is not visited yet. Hence this is again a dead end. We are not getting solutions. Again we'll go and backtrack. Do you have any other path from here? Yes. What is that? A to D, D to E, E to C. Now from C we have C to A. B is not visited, so we'll go and visit B, C to B, and B to A. So this is one of the solutions. So remember that Hamiltonian cycle problem, we are going to find out Hamiltonian cycle by visiting all the vertices exactly once. That is only basic things, and we can find out more than one solutions for the given problems. Of course, that is depends on the problems. Maybe some problems will get no solutions, some problem will get one solutions, some problem will get many solutions, right? Those all solutions are here called as all feasible solutions, okay, because all solutions are satisfying their term and conditions. Yes. So thank you very much for this session. We'll meet you again in the next class.